Hey guys, Yunane here, and welcome to episode 2 of my Unreal Engine 4 Blueprint tutorial series. In this episode, we will be making a laser trip mine. Okay guys, let's get started. Let's go into the Blueprints folder, and let's make a new Blueprint class. Let's base this on an actor, and let's call it laser trip mine. That's a good name. Okay, let's open that up. And let's start constructing our laser trip mine. Now the default scene route is fine here, but it's not the right shape we want it. We want it to be a box. So let's add a box mesh. Let's just add a cube. There we go. Cube. Let's call this the mesh. That's fine. Let's add a scene component as well. This scene component will be the root of our object. So let's drag that onto our mesh. So the mesh is the child of the root. Let's set the mesh. It's a little bit big, so let's change that a little bit. Let's go to the scale. Let's change the x to 0.1, dy about 0.4, and the z to 0.3. This way is sort of a rectangle where the laser is coming out. Now we need to change, what do we need to change as well? We need to change the location a little bit. It's in the middle now. We want it to stick on the wall, and the wall is going to be where the green line is over here. So we need to move it a little bit this way in the x-axis. So let's do it by 5 in the x-axis, and we can check if it's on the line now. Yep, it's on the green line, so that's good. The wall will be here, and this will be the object sticking to the wall. Okay. Now we might need a material here, so let's do a crazy material. I don't know, the door material. It looks a bit like a futuristic trip mine. Okay, let's keep it like that. Now the other thing we need, we're going to add to the mesh. I'm going to be adding a arrow. The arrow is going to be the starting point where the laser is going to start. So let's change this to the laser start point, and let's connect that to the mesh so it's always coupled to the mesh. Now we need to adjust it a little bit, so let's change the location. Location is 50. We can change the scale a little bit as well. It's a bit big, so let's change it to 1, 1, 1. Okay, maybe that's a little bit small, but you can still see the arrows, so that's fine. Okay. We could adjust the scale in the x-axis a bit, like, I don't know, 10. Okay, that's a bit much. Let's change it to 5. So, now you can see the arrow, and it's red at the moment, so let's change that to, I don't know, change it to bluish. No, that way it's even easier to see. Now it won't overlap with the movement arrows. Okay. Now the last thing we need, no, not the last thing. We need a trigger box. This trigger box will be used to trigger the trip mine. So let's add a collision box, box collision. Let's call this, well, we can keep it box if needed. Doesn't really matter that much. Okay, we need to adjust the location a bit. Let's go forward in x by 11. Then let's change the box extent because it's a little bit big at the moment. Let's change that to 1 in the x. In the y, let's go 8. And in the z, let's go 8 as well. Now it's a little box around the laser, which will be the trigger. And we also changed it by, so it's only one unit in the x-axis, because we're going to be scaling this box. We're going to be making this box as big as the laser will be. So that's why we set it to 1 unit at the start. Now this laser trip mine will be exploding, so we're gonna need a radial force. So let's add a radial force to this. Let's change this to explosion. And let's change the radius to, I don't know, 300. Let's change the impulse strength by, I don't know, 50,000. Yep, that's fine. Okay. Now we might need to adjust it a little bit in the x-axis. So it's in the middle of the trip mine. About that. That's fine. Cool. This way it won't explode inside the wall. We don't want that. Okay, let's compile this and save. Let's get ready for the next part. Let's get ready to spawn this trip mine. Let's go into the blueprints and let's go into first person character. Now all these things are all standard, so let's just keep those in there. It's fine. Let's start by using the letter T, or the key, the T key. We're going to use the T key to spawn our object on the wall. How are we going to do this? We're going to do this by using a line trace by objects. And this line trace by objects is gonna come from the first person camera. And we're gonna get the world location. World location. This will be the start. And then we're gonna use the same thing we used in our other tutorial. We're gonna get the forward vector. Get the forward vector. We're gonna multiply this. Oh, wrong, not x. We're gonna multiply this by about, I don't know, 500. We don't want it to be too long. We want the person to walk up to the wall. So let's do about 500 units. And let's add this to another vector. Let's couple it over there. And oh, let's go with this. And let's connect that to the end. Okay. Now the line trace for objects still needs a object type array. So we need to add a new variable. Let's call this world static. We'll be only adding these laser trip mines to the walls, so we don't want them to be added to the physics objects in the world. So let's make a new variable. Query. Search for query. It's the eObject type query. Let's make that an array. Let's add a new element, and let's add the world static to that. Now, if you want to add these laser trip mines to other objects, you could, but you need to change this to the physics body or world dynamic, depending on what you want to stick this one to. So let's do the world static. The world static is usually the walls. And let's drag this into our game here, or into our blueprint, sorry. And connect this to the object types. Now this error will disappear now, because we have the world static connected. Okay. That's all we need to do for the line trace. Now, if we hit something, let's first check with a branch if we actually hit something. Now, if we hit something, we want to be spawning our laser trip mine. I don't see it here. So let's deselect the context sensitive checkbox. And it's still not there. Okay, that's fine. Let's do that a little bit differently. Let's break our hit result first. Break hit result. This will be the object we hit. And let's check our, yeah, we need the location and we need the normal. I'll explain that in a minute, but first I need my spawn actor here. Spawn actor from class. There we go. Okay, select the class. That's going to be our laser tripmine that we made. Cool. And now we need the transform for the location and the rotation. We need to spawn this thing in. So let's grab the location. Let's make a transform from that. Make transform. This way we get the location, rotation, and the scale. The scale is going to be 1, 1, 1. And the transform is going to go in here. Now for the normal, we're going to be needing the rotation for the tripmine for the wall. So if you paste it onto the wall, we need to know which side the wall is on. So if you place it on the floor, the wall, or the ceiling, it will always get the laser pointing outward from that wall. So we need to rotate this vector by using the function rotation from x vector. There it is, from x vector. And this will rotate the object always the correct way. Cool. Now we can already test this out, but let's put a comment box around this and call this place laser tripmine. Cool. Now let's see if this works. So let's save. Let's go into our map. Oh. And let's place a laser tripmine. There we go. As you can see, it's sticking to the wall. It's perfectly aligned. And if we place it over here, it's nice and sticking to the right wall again. And if we place it on the floor, it's also properly rotated. So this is the rotation we get with that rotate when we rotate the normal. Cool. Now we got this thing sticking and it works. But we need the laser, so let's do that in this next part. Okay, we need our laser. Let's get started on the laser. We need a new material, so let's make a new material. Let's call this laser material. Okay. Now there's a couple of things we don't need. So let's change the blend mode to translucent. And let's change the lit to unlit. Okay, that's all we need for the laser material. Let's add a depth fade. Depth fade, there we go. Now let's 1 minus that. And let's multiply. Okay, let's multiply this again. This one is going to be multiplied by 50. And let's add that. And that's gonna go into the emissive color. Okay, now we need a particle color here. Particle color. And we need to add this to the multiply. And we need to add this to the add. Okay. That's all we need for the emissive color. Now we need to add a text chord. So let's go in here and search for the texture coordinate. There we go. Let's drag that in here. And let's connect that by a mask, component mask. Let's disable the red. We only need the green. And let's subtract that. Subtract that by 5. No, 0.5. There we go. Let's multiply that. Let's multiply that by the same number. And let's 1 minus that. And let's power that by 20. Okay. Need to move it a little bit. Nope. Nope. Need to move this a little bit. Okay. Now this number we're going to clamp. -0, max 1, that is good. And we need to multiply this. Multiply. I'm going to just connect it to the other one, to B. And A is going to be multiplied by the alpha. Now the multiply then goes into the opacity. There we go. Now this is all we need for our laser material. I have no idea what all these functions do. I just stole this from the contact example. I saw a nice laser material and I'm just copying it over. Okay, that's our laser material, so let's save that. There we go, takes a little while. I think it's time to make our laser particle system. Let's get started on that. Let's go into our first person example map. Let's go to, we don't really have a folder for the particle system. So let me just put it in textures as well. It doesn't really matter that much. Let's add a new particle system. And let's call this laser particle. Okay. Let's open it up. And let's change this a little bit. Now this is going to be a beam. So we need to set the type data to beam data. Okay. The beam data. Let's start with that. The max beam count is going to be 1, so that's good. The speed is going to be 0 because it's going to be an endless beam which doesn't really move. The rest is all fine. Beam method is target, that's fine. Okay. Now in required, let's set the material to our new laser material. There it is. Laser material. And let's go into spawn. As you can see, it's already doing something. Not the thing we want, but it's getting there. Let's go into spawn. We need to adjust the rate a little bit. The rate is going to be 1. It's going to be 1 particle only. And the rate scale is going to be 1 as well. But that's already set to 1, so that's fine. Okay, let's go to lifetime. And set the min and max of the lifetime to 1. Okay, that's already set to 1, so that's good. Okay, initial size. Let's set the size of the beam. It's going to be a constant, distribution vector constant. And let's set it to 2 in the x-axis. So it's going to be 2 units wide. Okay, now we don't need the velocity, so let's remove that. And we also don't need a colorable life. We're going to be adding a couple more here. We need an initial color. So let's go to color, initial color. And let's go to the start color. And let's adjust these values a bit. I'm going to go with a 400 by 22 by 22. Oh, maybe 20. Okay. This is a nice red UE it gives off. I don't see it yet in the viewport. That's fine. Now the alpha is going to be set to 1, so that's fine. Okay. Now we need a source, because it's a beam, so it needs to needs a source and a target. Well, a target is not really needed that much, but when we add the target, it will be a little bit better. Okay, the source. As you can see, we see our beam here. It's looking like a beam already, so that's good. The source is pretty much fine at the moment. We can set it to a user set here, the method, but okay, in the source you want to be setting the constant. The source you want to be setting to 0, 0, 0. That way you get a nice line. It's nice and straight now, so that's good. For the rest, it's fine. The source, the target is the important part. So let's add a target. Let's set the target to user set, and let's change the target name to endpoint. It's going to be our endpoint for our laser. And let's set the target to be 300 in the X, 0 in the Y, and 0 in the Z. Now, as you can see, it's a nice little laser. The camera is a little bit wonky at the moment, but that's fine. Yeah, looks like a laser. Looks pretty cool. Okay, that's all we need to do in the particle system. So let's save that. Let's go into laser tripmine. Let's go into the event graph. We're already in the event graph. That's good. And let's remove all these. Let's add the event begin. Nope. Okay, now that we have the event begin play, let's add our box, which is our trigger box. And let's set the collision on this to disabled for now. First we want to be generating the laser and the trigger box before we activate it. So let's set this to no collision. That's good. Okay. Now we're going to be needing one variable, and that's going to be our beam endpoint. So let's add a beam endpoint variable. It's going to be a vector. That's good. And let's drag that in here. Let's set the beam endpoint. Okay. We got our laser start point. I'm going to be needing the get world location from that. So get world location. And that's going to be our starting point. So let's move that up here, because we are going to be doing a line trace again. So let's add that line trace first. Line trace. Let's do by channel. That's going to be our starting position for the line trace. That's going to be the laser start point we added. So the arrow in the viewport, this blue line here. That's going to be our start point, which is here. Okay. Now we want to be extending that endpoint indefinitely until we reach, like, I don't know, 5,000 units. Let's make the laser max 5,000 units. Let's add a laser start point again. Let's get the the forward vector. Forward vector. And let's multiply that by 5,000. 5,000 is the maximum distance this laser will be going. You can up that if you want. And let's add that to another vector. Let's remove that and let's reapply it to that one. Now we just need the world location from the laser start point. The world location. And that's going to be added to this one. Okay, so that's going to be our endpoint. The endpoint is going to be 5,000 units further than the laser start point. Okay. Now that we have that, we need to check if we actually hit something. So let's go into this and branch off the return value. So did we hit something? Let's break our hit result as well. break hit result. Now if it's false, so if we didn't hit anything, we're going to be setting our beam endpoint, or actually if it's true, if we hit something, we're going to be setting our beam endpoint, which I still didn't set here. I need to reconnect this actually differently. I need to connect this to here and then to the end. There we go. Sorry. The beam endpoint is the ending point, and that goes into the line trace. So we set the variable here. Now if we hit something, we want to be updating that beam endpoint. So let's set our beam endpoint to the location where we hit, just so it's updated. And then we want to be creating a beam. Now I want to be making a couple of functions for that. Let's add those functions first. So let's go into function. Let's add a create beam function. And we're going to use another function, which is going to be called skill trigger box. Okay, let's go into the create beam. And we're going to be needing two inputs. The start location for the beam, which is going to be a vector, and the end location, which is going to be also a vector. Okay. Now, what we're going to spawn here, spawn emitter at location. This is going to be the laser particle we made. So let's select the asset. Let's go to laser particle. There it is. And let's set the start location to the location here. Oh, saving. That's all good. Okay. Now that we're done with that, we need a new variable. This is going to be our laser beam. The laser beam is a variable we're going to use to destroy the laser beam later. So let's add that. And let's make this a particle system component. And let's add that to the return value here. Cool. Now from that component, we're going to be setting the beam endpoint. Beam endpoint. And this endpoint is going to be the end location we added here. So this way we have a function which creates our beam in the set location we set here. Okay. Let's compile that. That's fine. Let's go back to our event graph and let's set it up. We'll be going from the false into the create beam. It's all the way over here. Function create beam. And this will take our, as a start location, it will take our world location from the laser point. So we can use the laser start point again. Can get the get world location. And that's going to be our start location. And our end location will be our beam endpoint. Get. Oh. Sometimes it's hard to move these. Okay. Now the set here is going to be set to the create beam as well. This way, in the if statement, when we've hit an object, so if it's true, we set the beam endpoint to the new location. If we didn't hit anything, we set it so it's false. The beam endpoint is still the same endpoint we set in the beginning. So it's going to be 5,000 units long by default. And that's going to be make the beam. So that's good. Now we need another function here. That's just going to be our skill trigger box. So let's go into the skill trigger box function. And let's make that function. Now this function is going to be a little bit complicated, but I'll try to help you through it. Let's set our output, our input, sorry. Set that to the end location. So the end location is going to be a vector, which is going to be the end location of where the box is going to be. Let's get the laser start point. And let's get that world location. Okay. Now this world location will be minused with another vector by the world location. This way we have the vector between two locations, and we need to get the length of that. So let's get the length of this vector. Vector length. Now we know how long this this box needs to be. And we're going to divide this. Divide this by a float. I'm going to divide this by 2. Now let's make a vector with this. Make vector. And let's put it in the x-axis. We only want to scale this box in the x-axis. The rest of the box, the y and the z will be fine. That's always set. The length of the x is the one that we want to be setting. Okay, that's fine. Let's drag off this to set relative scale, but we don't need to drag from this, we need to drag from the box. We want to be setting the box, so let's put the box here. Set relative scale, 3D. This will be the function we use to scale the box, so that's fine. Okay, let's cancel out a save, otherwise it's going to be in the way. And let's add this to the new scale. Okay. Now we've scaled it, but the position is still in the middle of the trip mine. Now we don't want that. We want to move the scaled box to the right, and we're going to do that by making another vector from this divide here. Could just use this return value actually. I'm gonna add that to another vector. Let's do this one instead. Okay. And let's use the function. No, let's drag from the box again. It's just easier if you drag from a box because you see the relative functions from that for that object. Let's set relative location. Set the relative location. That's fine. Let's get the relative location from this box, by the way. Get relative location. Let's add that to the vector, the other vector. And this is going to be our new location. Okay. So what we do essentially here is we got the start location over here. We got the end location. We subtract that from each other. We get the length. So we get the distance the laser needs to go. But because the box is in the middle of the laser, we need to divide it by 2. We need to make a vector from that, only in the x direction. The y and the z is fine. And then we use that value again to set the relative location. Let's go back to the event graph. Now in the event graph, we're going to be using that function. So scale trigger box. And we're going to be using the beam endpoint as the end location. Okay, and at the end, I'm going to be using the box, the trigger box, and set the collision back to on. collision, collision enabled. There we go. Okay, that's all we need to do. We need to compile here and save. And this should be it. Let's comment that. Let's call this create beam plus trigger. There we go. Create beam plus trigger. Let's see how it works in game. Save. Let's compile this as well. Save. Let's go to the map. Let's play this. And let's place one. Wow. Look at that. It's actually working. Now we don't know if our trigger box is working at the moment, because it doesn't do anything when I jump through it. But let's check if the laser goes in the proper direction on every wall. Okay, that works. This works. And then the floor works as well. It goes 5,000 units long, so you can see it's pretty long. And this wall, yep, seems to be working fine. Very nice. Okay guys, I made a little mistake here in the scale trigger box. As you can see, this make vector here, it's going to be the scale. And I set these Y and Z were on 0. They need to be set to 1. That's really important. The other thing is, I need to make a new vector here, because this is a vector that's not going to be a scale, it's going to be a position. So I needed to make a new vector where the Y and the Z were 0. And those will be added to the relative location. Now it's important to do this, otherwise it won't work. Because we were scaling the X, Y and Z, the Y and Z were set to 0, so I couldn't see the box because the box was 0 by 0. In the X-axis it was 5,000 units long, but in the Y and the Z it was 0, so you couldn't see it. Now, okay, that should be fixed now. In the viewport I set the box to be not hidden in game, so you could actually see it. And if you go into the play, into the map, and if you place it now, you can see a box. You can see lines around it, which is the box around the beam. That's just going to be our overlap trigger. Okay, let's get started on that overlap trigger, and let's make it explode when you overlap that box. Let's select the box here and use onComponent begin overlap. Okay, first thing we're gonna do, the other actor, we're gonna cast this to the first person character. Now that we're gonna check if it's the first person character that's overlapping the laser. Let's spawn a explosion emitter. So let's spawn an emitter at location. This is going to be our explosion. P explosion. And we're going to just get the actor location. Get actor location. This is going to be the location where it's going to explode. Now we need to fire the impulse on the explosion force. Fire impulse. There we go. And let's connect that to the spawn emitter. We're also going to need a sound, so let's add that as well. Let's do a play sound at location. Let's set the explosion. Let's use the explosion cue maybe. Yeah, explosion cue is fine. And we need to set that location. So yes, let's use this location over here. That's fine. And after we've done that, we need to destroy one of our components, and that's going to be our laser beam component. So let's drag the laser beam in here. Get. And let's destroy component. It's really important that you destroy the laser beam component first before you destroy the actor. Otherwise you won't be able to get the laser beam variable back. Okay, after we destroy the laser beam, let's destroy the actor. Destroy actor. And that should be it. Now we have our explosion, so let's comment that out. Explosion on contact. There we go. Let's test it out. Let's save, compile. Let's play. And let's place it. Okay. You gotta be careful that you don't place it right in front of you because it will explode right away. Okay. Seems to be working. Nice. When you move through it. Whee! It doesn't damage us, but that's fine. You can always add that if you want. And the laser seems to be pointing correctly as well. Nice. Okay. Hope you like this tutorial. And let me know if you want to see something else, or if you got any ideas for other tutorials. Just send me a message. And take care.